Hello, in this video I'm going to talk about bivariate regression, which is the first form of regression that we're going to talk about in this class, but we're going to cover many other forms and as they get sophisticated and more complicated forms of this. But bivariate's the easiest and it's the one we're going to start out with. Now you should have already read the written lecture material that I posted online, so you should have at least a basic understanding of what a bivariate regression is. So in this video what I'm going to do is show you how to conduct a bivariate regression in SPSS, starting with the assumptions and also how to interpret the results from that test. I have once again provided a data set as an example that you can download from the website, from the Blackboard site. This is called Data Use and Example Unit 5.2. As you can see, this data set has two variables. Switch to our variable view and we can see that one is self-reported crime committed in the last year, and the second is a rating on antisocial personality scale. So where do they fall on that scale? And how I set that, this is made up data, but how I set it up, the made up anti-personality scale ranges from 1 to 10, with 10 being higher on that scale. And then self-reported crime obviously is, as that becomes higher, it means that they've committed more crime. Pretty straightforward there. But let's imagine that we conducted a study and we want to see what's the relationship between these two variables, and we hypothesize that as antisocial personality scores increase, which would indicate a higher level of antisocial personality disorder, or at least a higher rating on that scale, so they have more characteristics of an antisocial personality. As that increases, crime's going to increase. So that's our hypothesis here. And okay, we want to test that. A good way to test that might be a bivariate regression. We're looking at a relationship here, and let's say we want to go a little bit further than what a correlation is going to give us. So, we decide to conduct a bivariate regression on these, but the first thing we need to do is actually test our assumptions. So the first variable that we want to actually test isn't actually an actual assumption, but it's just checking your data to make sure there's no problems with it. We want to actually check for any outliers in this data. And just one real easy way to do that when you're looking at relationship between variables and you're seeing if there's any big outliers with that, you go to your graphs, legacy dialogues, and we do a scatter plot, which we covered in a previous unit. But to review there, go to scatter plot, simple scatter, click define. You want to put your outcome variable, which is self-reported crime in this case, in the y-axis, and our predictor variable in the x-axis. And we can just simply click OK here, and we're going to get our output here that we can see. Well, and by looking at this output, we can see there's this one variable up here that is kind of way off the mark. And just doing a visual inspection, we can pretty easily assume that that's an outlier, and there must be some type of problem there. Now, either somebody is significantly different than the rest of the sample that we used, or it might be a coding error. So let's go back to our data view and scroll down, and we can see that case number 52 down here is a 3, but has a 33 in the amount of crimes, which is much higher than any of the rest. And in this case, we're going to imagine that that was a coding problem. So if you just change that to 3, which you guys should do in your own example data, that should fix that problem. So now if we rerun that graph, we can see that this no longer appears to be a problem. There's, at least on that indication, there doesn't appear to be many outliers. Now I'll show you guys a few other ways to search for this after we actually run the data, but that's just one thing you always want to do when you run a regression or some type of looking at relation between variables is run that scatter plot on the variables and just do kind of visual inspection of what you have here. So that's the first thing we want to check, but that's not necessarily an assumption. The first actual assumption we want to check is level of measurement, which when you're doing a bivariate or even multiple regression here, we're just going to focus on bivariate here, but you want your dependent or outcome variable to be interval or ratio, which in this case is self-reported crime, so we definitely meet that. And then you want your predictor variable, or variables if you're doing a multiple regression, you want those to be either interval ratio, or you can also sometimes have categorical variables. But we're going to hold off on that categorical side until next week, and that's what I'm going to cover for most of that week, is how to conduct an analysis using those variables, because it does change things a little bit. But in this case, our antisocial personality scale, ranging from 1 to 10, meets those characteristics of being interval or ratio. Some people would argue that scales don't necessarily fall under that, but usually if it's a scale variable that has a lot of other variables combined, it's considered to meet that criteria. So just by looking at our data there, where we can tell, okay, we do meet that assumption, level of measurement is met. The next thing we want to test is linearity. Is there a linear relationship between these two variables? And actually, to do that, we can once again go back to our scatter plot. And if you did this all the first time, we wouldn't have to go back through and rerun it. And just kind of visually inspect that and see that, yeah, there's a lot of spread here, but it does appear to be some type of linear relationship going on. Just as a quick review, I put up a picture here of a linear relationship. Here's an example of a nonlinear relationship, and there's many different types of nonlinear, but essentially, if you look at that scatter plot, we can usually get a pretty good indication of whether we have a linear relationship or not. So it appears that we meet that assumption as well. So let's move on to the next assumption. Okay, the next assumption is that there's no measurement error, and that essentially means that we didn't make any mistakes measuring the data. This goes back more to research methods, and that what you're measuring is actually what you think you're measuring. So are we actually measuring antisocial personality with that scale? Is the self-report actually capturing real crime? Now this is all methodological issues, so we're not really going to cover those in this class and just assume that those are met. But when you guys take your research methods class, you're going to get into that a lot more. But in this class, we'll just assume that we meet that. Okay, the next two assumptions get a little more complicated because they deal with the error terms or residuals in the model. Now, this will become familiar as we talk about, but residual, again, is just the amount of error in the model. And let's say this wouldn't represent our actual line of best fit, but if we fed a line of best fit through this data, then the amount of distance between that line and each one of these dots, which represents a person. In this case, okay, let's say we're looking at average amount of drinks in a night, or average amount of drinks on a night, and the amount of fights a person gets into over here on the other axis in a month. And so each of these dots represents a person, and our line of best fit, which is also called the regression line, is what we're going to use to try to predict this. And the residual is essentially this distance between the line and each of these individual dots, and that represents the error that if we used our regression line to try to make predictions predictions around those people, that's the amount of error that would be present there. And there's two assumptions that deal with this that we want to be concerned with. The first one is that we have normally distributed error terms, or residuals, to use the other terminology there. And the second is that there's no autocorrelation, which essentially means that no one observation is too strongly correlated with another as far as the error terms. Now both those are fairly complicated when we get down to it, but for this first introduction here with bivariate regression, I'm just going to show you guys how to interpret it and probably get into a little more detail when we get into multiple regression behind what do those actually mean. So both of those we can actually test as part of the normal steps that we do in running our regression analysis. So I'll kind of put those on pause for now and come back to those as we actually run the regression.